Hey there, in this video we will see about variables in Go, basic data types and composite data types. In basic data types we will cover some of the widely used data types such as integers, float, string and boolean. In composite data type we will look into arrays and slices. Struct is also an composite data type which we will cover in the next video. Without wasting much time, let's get started. First, let us understand how we can declare and initialize a variable in Go. There are two approaches to this. So the first one is, let's say we can define keyword called where, variable name, the data type and equal to the value. So this will look something similar to this. Let's say I have where, my variable name is age, it's of type int and the value is 30. So here we are initializing a variable age of type int and the value would be 30. The other way to define a variable is using a shorthand approach. In the shorthand approach, what you do is you specify the variable name equal to semicolon equal to the value. In this case, the compiler infers the data type automatically. So this syntax would be inferred as the above. Both are same. This is preferred because here it is you define it in a very short way, and hence this is what we will be using in most of our videos. One thing to notice is when you are using a shorthand approach, this approach can be used only for local variables. That is anything within your function. Let's say I have a function get and I am defining some variables here. This approach can be used only for this local scope. Okay, so we will see this in action in VS Code in some time. But before that, let us just cover some theories on basic data types and composite data types. So next, we will look into basic data types in Go. Okay, so there are basically four data types that we will be looking at. One is the integer, float, string and boolean. Okay, so in string there are various types that are supported in Go, such as unsigned int 8, unsigned int 16, so on, similar to int 8, int 16, int 32, int 64, etc. So these are the bits: 8-bit, 16-bit, 32-bit, 64-bit. If you don't want to get into details and specify bits, you could just use int. And what this would do is, based on your operating system, whether it's a 32-bit or 64-bit, this will be inferred. If you are in a 32-bit system, it will be inferred as int 32. If you are in 64, it will be inferred as int 64. But you can just define it as int and let the compiler do the needful. One thing to note here is when we say uint 8, it means unsigned integer, that is all positive. So 8-bit would mean 2 raised to 8, that is 256. So basically 256, the value from 0 to 256 can be contained within uint 8. So that would be 0 to 255. Similarly, in let's say integer 8, since this would support both positive and negative, the value will still be same, 2 raised to 8, that is 256, but it would be ranging from -127 to 127 and so on. Whatever values that cannot be fit into int 64 you would have to use float. Float has two types, float 32 and float 64. If you don't want to specify the bit, you can just define it as float and that will still tend to work. One thing you need to know is you could also typecast between one data type to another of a similar type. For example, both float and integers are numbers. So you can always take integers and typecast it to or convert it into a float. But the other way would not make sense, because let's say float can contain a larger value range. So let's say this bucket is my float bucket, and let's say if I have a int bucket which is smaller than float, you could pour in this water into this bigger bucket because these values will always contain within my float range. But the other way around is not true. The next data type that we will be looking at is string. String is string. There is no variant, no surprises here. So you could just define something like message colon equal to some string, and this would be termed as a string data type. Boolean also has no surprises. It supports two values, false and true, and based on Boolean you can take some kind of a decision, like if some Boolean variable do blah blah blah, else do something, right? So these are the basic data types in Go. The next what we will look into is composite data types, that is arrays and slices. Arrays are basically a data type in Go which would help to contain data of similar types. They are fixed in length, so once defined at the compile time, you will not be able to extend it as part of your application logic. Okay, in order to define an array, you need to specify the variable name. Let's say I have something called days. Okay, I'm using a shorthand operator. You need to specify in bracket the length. Let's say there are 7 days in a week. That will be of type string. And if you want to even initialize the values, you can give those values in curly braces. So you could give Monday, Tuesday, Wednesday, and so on. If you notice, we are defining the length during our compile time. If you don't want to specify this value but you want the compiler to take care of that, you could replace it with ... and the same thing here. So based on the number of values that you specify, the Go compiler will infer the length when it tries to allocate it in the memory. Okay. The other important thing that you need to understand is arrays in Go are passed by value and not passed by reference. So what this means is, let's say you had an array days with some values and you have a new variable, let's say new days, and you bring this days here. Let's say you say new days equal to days, and you make any change in new days, like you put some value here. This will not change the value at index 0 in the original array, because this is passed by value, and the moment you assign, it creates a copy of the original into this. So whatever modifications you make to the new variable, it will only be applicable to that and not to the original array that was being assigned. This is different to other languages where arrays are considered to be passed by reference. The same applies if this value, this array was passed as an argument to a function and there was some modifications done within that function, it would not be reflected in the original array because the copy is created even in that case. In order to overcome all of this, there is another data type that is available, and those are known as slices. Slices do not have data of their own, and they are basically created from the original array. So now let's say if I had this days and all these things, the slices are nothing but, let's say, slice variable equal to days, and it could be something like start with 1, index 1 up till 2, that is, this is inclusive and this is not included. So this is how slices work. Now any changes you make on this slices variable here, right? Let's say I do slice where, and let's say I change some at some index, I say some value, new value, it will be reflected in the original array as well. So that is one of those characteristics of slices. The other thing is you could always define slices in using a make function. So you could say slice where equal to make, okay, which would take the data type, I'll call it t for now, the length and capacity. Now what do we mean by capacity and what do we mean by length? This capacity is actually optional, and if you don't supply capacity then it will be equal to the length. Now let's say we had this days array which was having a length of 7, and we created a slices from 1:3. So basically it contains 1, 2, 3 values, right? So the length of that slice becomes 3, okay, and the capacity is the total number of elements that are present in the original array starting from the index. So now here the slices started from index 1, and though it ended at 3, but in the original after the index 1 there was 6 values, right? So the capacity would be 6, okay. This is one way. The other way to define slices is, let's say, slices where equal to, you need not supply the length, define the data type, and you could initialize the value. As we saw previously, arrays are fixed, but slices we can always append. So there are various methods that are available, like append, where you could take your original slice and you could add some new value to it. So it allows us to increase the size of our variable, right? If you had a slice of type value 7, the length 7 initially, but then you append, you could double or increase the capacity. Similarly, there are various other functions like copy, etc., where you can copy from one slice to another and so on. Okay, so let us see this in action. Will not do anything deep though, but just try to understand how to define variables, how to define arrays and so on. Okay, so I will go to my VS Code. I have a folder data type. I have main.go file. So I will use package main, which will define the main function, that is the skeleton needed. So first let us see how we can define various values. So let us define a message variable using the longer approach, that is where followed by the variable name, let's say message, data type string equal to value, let's say hello. If you notice, Go is complaining and it is throwing an error, that is we have declared or we have defined a variable but we are not using it. So Go is very strict, so if you are defining something you have to use it. Okay, so in order to get rid of this error, what we will do is we'll just do a println and we will print this message. Okay, in order to run this, you can go inside the data types, go run main.go. Okay, so I have this main outside, so I'll move it inside. Okay, and let's execute this again, and you see hello is printed. This same could be defined using a shorthand approach. Okay, so in order to do so, give the message or the variable name colon equal to the value. Okay, if you run this, it will still print hello. So this is the shorthand way to define a variable. Here what Go does is, based on our value, it will infer the type. So here, since it is hello, it will infer the type as string, as you can see in the tooltip that is being displayed here. Similarly, if I had changed this value, let's say from hello to 1, it will infer this as integer, as you can see. Okay, great. Similar to this, you could also define integers, float, etc. So just quickly we can try this out. Age 30, and we could print it. Print ln age. Okay, this is the way using shorthand. Similarly, if we had to use a general approach, we could define where age int equal to 30, and this would still mean the same. Similar to this, we have Boolean as well. So you could do is allowed, let's say, variable name, and we define it to true. You will notice the type inferred is of bool. Bool equals to Boolean. And you could use this, let's say, in if, like if is allowed is true, I want it to print something called print ln you are allowed. Else we could print something like sorry, access denied. So here, since our value is true, it should print you are allowed. If the value was false, it would go into the else and it would print sorry, access denied. Great. So here we saw the basic data type. So let us just comment this out and start looking at arrays. In order to define array, you could use the type bracket, specify the length, define the type, and in the curly braces you can define the values. So let's say I have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. Okay, great. So I need to use this variable, so I will do print ln this. So if I run this, it will print the entire array, and this is of length 7. If I don't want to specify this length, but we want the Go compiler to infer it automatically based on these values during compile time, you can replace this with 3 dots and this would still work. So if you want to see the length, you can use the length function and provide the array there, and if I print, the value is 7. Now let's say if we had a new array, let's say new days, and I assign these days to new days. Okay, and let's say I print that array. Okay, so what I will do is I'll print the original as well as the new days. Now what we will do is we will change the first index, the value at the 0th position, to say Mangalwar. And now if I run this, you will notice my original, right, that is this one, is not changed despite we changing the new days 0. If we had tried this in another language, we would see changing anything in the assigned or the assigned array, it would also make that change in the original array, because in other languages arrays are passed by reference, but in Go it is passed by value. So any change that you make in the assigned ones won't modify it in the original one, because the moment you do this, Go creates a copy of the variable and all the modifications are made on the copied variable and not the original one. In order to overcome this, we use slices. Slices, as we saw, they don't have data of their own, but it does provide capability that arrays don't, that is increasing the length, having passed by reference and so on. So let's say we define a new slice, we'll say day slice. Okay, and what we could do is we could use this without specifying the length. Okay, and we could do fmt.println day slice, and you run, it would still work. So this becomes a slice. But now if you see, I'll just copy this everything, I'll copy and I'll comment this out, I'll comment even this out. Okay, and I'll paste it here. So I'll create something called new slice and I'll assign day slice. Okay, and I will change the 0th one and new slice here. Now let us run this and see what is the output. If you notice, I made a change to my 0th element in my new slice, and that got reflected in the original one as well, because slices are passed by reference in Go, unlike arrays. That's all I had for this video. If this was helpful, then do subscribe to my channel and like this video, share it among your friends. I will see you in the next lecture. Until then, happy learning.